Hello, class. Back with another office hours question about optimization. So here's the rough setup here. We have this function f of x equals x plus 5 to the minus 2. Its graph looks something like this. That's more than enough of the graph to do the problem. And we're going to pick some point along this graph, anywhere you like. And then we're going to draw in the tangent line. So this in blue here, this is the tangent line at the point xy to the graph. And I want to know, this is the question, what is the largest area that this triangle here can have? The triangle with the y-axis, the x-axis, and the tangent line itself as the three sides. Okay, so that means I need to find the equation of this blue line. But I'll go ahead and label this as B, this is H, and I will say, okay, so what is my thing to optimize? My thing to optimize is the area of this triangle, which is 1/2 of the base times the height. And then my constraint is that my point xy has to be on the graph. So my constraint is that y equals x plus 5 to the minus 2. Okay, so now I have to do a little bit of work here because as it currently stands, my constraint is in terms of x and y, and my thing to optimize is in terms of b and h. So I want to sort of fix that by finding the equation of the tangent line. So to find the equation of the tangent line, I'm going to start by finding the derivative. So y prime or f prime or whatever you want. It is minus 2 times x plus 5 to the minus 3. And there's a chain rule here because there's a function inside a function, but the thing I multiply according to the chain rule by is the derivative of x plus 5, which as it happens is 1. If yours is like a 2x plus 7, again, be sure you don't forget the chain rule here. Okay, so then I want to know, okay, well, what is the slope at this point x comma y? So that is to say, the slope is, well, it is y prime of x. It's literally this. Okay, now I'm going to go ahead just so that I can keep track of what's going on. I'm going to have x's and y's in my tangent line. So I'm going to go ahead and call this point x naught, y naught. So then I'm going to remember that's my constraint, is that y naught is x naught plus 5. So my slope here of the tangent line is y prime of x naught, which is going to be minus 2 times x naught plus 5 to the minus 3. Okay, so then I can ask, okay, so what is my tangent line? Well, my tangent line is then y equals minus 2 times x naught plus 5 to the minus 3 times x plus b. And I have to figure out what this b is. Also, please keep in mind, this b, this is the y-intercept b. It is different from this b, which is the base of this triangle. They just both happen to be labeled by b, but we'll fix that soon enough, because I'm going to figure out what this b is in terms of x naught and y naught. So how am I going to do that? Well, I'm going to plug in the point on the line that I know. Namely, the point on the line that I know is x equals x naught, y equals y naught. So then I will get y naught equals minus 2 times x naught divided by x naught plus 5 cubed. I'm just writing this as a fraction now just to keep track of things and keep things a little bit simpler, plus b. So what is b? b is y naught plus 2x naught divided by x naught plus 5 cubed. Which makes the equation of our tangent line y equals minus 2 over x naught plus 5 cubed times x plus y naught plus 2x naught over x naught plus 5 cubed. Okay, so now here's where I need to solve for the h and b of the triangle. So this just literally is the height of the triangle, because if you look back over here, the height was just the y-intercept. So h is that. Okay, the base is actually the x-intercept of the line. So to find the x-intercept of the line, I have to set this, sorry, not that. To find the x-intercept of the line, I have to set the equation of this line equal to 0. So that is, I'm going to solve 0 equals minus 2x over x naught plus 5 cubed plus y naught plus 2x naught over x naught plus 5 cubed. I'm going to multiply everything through. Sorry, I need to show you actually what was there. So I'm going to get this equation, and I'm going to multiply everything through by x naught plus 5 cubed, which is going to give me 0 is equal to minus 2x plus 2x naught plus y naught times x naught plus 5 cubed. So I'm almost to the point where I have solved for x. I just need to move the 2x over here. So I'll get 2x is equal to all of that. And then I can divide through by 2, which will give me x is x naught plus y naught times x naught plus 5 cubed, all divided by 2. Okay, so this is my x-intercept, which means this is the base of my triangle. Okay, so let me summarize what we know. We're trying to find the maximum area of a triangle whose height is given by y naught plus 2x naught divided by x naught plus 5 cubed, whose base is given by x naught plus y naught times x naught plus 5 cubed divided by 2, and subject to the constraint that, in fact, y naught is equal to x naught plus 5 to the minus 2. That's the statement that the point x naught, y naught is actually on the graph. We just spent all of that time finding the tangent line to. So I'm going to sub this into the height and into the base in order to simplify it a bit before I plug everything into the area formula. Okay, so I want this to be as simple as possible. Okay, so I plug y naught in here, so I'll get the height is. So this is 1 over x naught plus 5 cubed plus 2x naught. Sorry, let me back up a second. This y naught, it is 1 over x naught plus 5 squared plus 2x naught plus 5 cubed, and I could put this over one denominator of x naught plus 5 cubed, which means I have to multiply this by x naught plus 5 over x naught plus 5, like that, which means the numerator here is 3x naught plus 5. And that's much nicer for our height. Then our base, I want to simplify. And the base, I'll read off from here, it is x naught plus, okay, and y naught is, remember, going to be this. So x naught plus 5 to the minus 2 times x naught plus 5 cubed, all divided by 2. So this is now x naught plus, and notice 2 of these cancel with 2 of these, so I am just left with x naught plus 5 over 2. Okay, so let me combine these two into one fraction on the next sheet of paper. Okay, so that is to say the base, continuing along, is equal to 3x naught plus 5 divided by 2. Okay, so now we can come back to the area. So what is the area? The area is 1/2 the base times the height, which is 1/2 times 3x naught plus 5 over 2 times 3x naught plus 5 over x naught plus 5 cubed, which is going to be, if I want to write this out as one fraction, this. Okay, and we want to know where this is biggest. So, namely, how am I going to figure that out? Well, I'm going to take the derivative of this. Okay, so my a prime here. Okay, so this is my f. This is my g here using the... This is my f, this is my g. Here we need to use the quotient rule. So I'll go ahead and record over here for future reference. F prime is 18x naught plus 30. G prime is 12 times x naught plus 5 squared times, and then from the chain rule I also get a times 1. Okay. So my a prime here is f prime g, so that is 4 times x naught plus 5 cubed times 18x naught plus 30 minus fg prime, so minus 9x naught plus 30x naught squared plus 25 times 12 times x naught plus 5 squared, all divided by g squared, so that is by 16 times x naught plus 5 to the 6th. Okay, so what I'm going to notice here is that there's an x naught plus 5 squared in both terms and in the denominator, so I can cancel that. And there is a 4 in both terms, so I can cancel those. So I'm going to cancel out a 4 times x naught plus 5 squared from the numerator and denominator, which is going to leave me here with an x naught plus 5 times 18x naught plus 30 minus, and here it is going to leave me with just 3 times 9x naught squared, 9x naught squared, plus 30x naught, plus 25. Okay, and all of that is going to be divided by, I took out a 4 times x naught plus 5 squared, so that'll be a 4 times x naught plus 5 to the 4th now. Okay, now remember, what I really want to know is when this numerator here is 0. So I can go ahead and FOIL all of this out, but I only care about the numerator and when that is equal to 0. So I'm going to just multiply out the numerator here. And upon doing that, I'm going to get 18x naught, the numerator, 18x naught squared plus 120x naught plus 150 minus 27x naught squared minus 90x naught minus 75. Okay, and so this is a minus 9x naught squared minus 30x, plus 30x naught minus 75. Plus 75. So once I combine all of these terms, I get a minus 9x naught squared plus 30x naught plus 75. Okay, and I want to know when this is 0. So I'm going to divide everything in this equation by minus 3. So that's going to leave me with 3x naught squared minus 10x naught minus 25 equals 0. And then I am going to try to factor this. And upon looking at it, I see, oh, this factorization works. So I get a minus 15x naught and a plus 5x naught. So that means there are two critical numbers here at the end of the day. There is x naught equals minus 5/3, which is a little weird because it means the x naught's over here. So I'm taking the tangent line something here, but it still slices a triangle out in the first quadrant. So maybe that's right. And this one will give me an x naught equals 5, which will give me something way over here where I can look at that. Okay, so I need to try those. Okay, notice conveniently in this case, there are no endpoints that I really have to consider. So I don't have to worry about the furthest. I can go this way. And I also can go as far this way as I want. So I don't have to worry about those. I just have to figure out, okay, what is this area if x naught is minus 5/3? And what is this area if x naught is 5? Okay, so let's figure out these two. And then whichever of these two is larger, that's going to be our answer for what is the largest area that this triangle can have is. Okay, so for x naught equals minus 5/3, then this is not going to be too difficult to figure out, because if you look back to our formula for the height, you will see that that value, minus 5/3, makes the numerator of the height 0, which means it makes the height of the triangle 0. Now, in fact, actually, if you look here, this was our simplified formula for the base. It also makes that 0. So, in fact, at this point, x naught equals minus 5/3, what happens is that this tangent line actually passes through the origin, so it doesn't cut off any nice picture or anything like this. So this corresponds to area equals 0. Okay, so that is definitely not the thing we're looking for. So then I must be looking for what happens when x0 is 5. So when x0 is 5, I can go back to my formulas for the height and the base. So the height when x0 is 5 is 3 times 5 plus 5 divided by 5 plus 5 cubed, okay, which as it happens is 20 over 10 cubed, which would be 2 over 10 squared, which would be 0.02. Then the base, by our simplified formula for the base, which I'll remind you is this, was 20 divided by 2, which is 10. So then the area of our triangle is 1/2 times the base times the height, which is 1/2 times 10 times 0.02, which will be 0.1. And that is the largest area that our triangle can have. All right. Keep in mind, this is a really tiny largest possible area, but our original function, if you look at it all the way back at the very beginning, our original function was y equals x plus 5 to the minus 2 power. So anywhere here in this first quadrant, this function has a value that's much, much less than 1. So that means the height of this triangle is going to end up being somewhere less than 1, which means the area is not possibly going to be that big. So this does check out if you look back at the original problem. Anyway, I'll wrap up there for now. Until next time, be well.